All right, section 9.4 is called series, and it follows pretty much what we learned in section 3 about arithmetic and geometric sequences. It's the sum or summation of a sequence, okay? And most of these will be finite sequences because, I mean, it's kind of impossible. It's not impossible, but it's hard to wrap your mind around trying to find an infinite sequence because infinite means it goes on forever and ever and ever. But we will talk about that kind of in the end about how you might be able to do that. Okay, so again, there's some formulas. This is arithmetic. This is the formula to find the sum. It's pretty straightforward. Okay, n is the number of terms you want to sum. So if they say find the sum of the first 40 terms, you would use 40. So n is the number of terms that you want to sum. A1, I hope that we all know what A1 is. This is the first term. AN is the last term. So let's say, for example, we said that we wanted the first 40 terms, and so our n would be 40. So this would be the value of the 40th term, okay, which is not 40. So n would be 40, but this would be the value of the 40th term. So you might have to go back to the equation from the last section and find the 40th term's value if they don't give it to you, okay? So this is, I will say last term, but it's just the term, you know, the ending term that they want, the first 10 terms, and you do A10, that kind of thing, okay? So last term, all right? So that's how you use that formula. I think this formula is pretty easy, and you may have even used it before. So I decided to do like a word problem that might show up to kind of ease your mind on those. Okay, so a corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats. So guess what we're doing? Adding 2. So that means arithmetic. Then the row preceding it. If the top row has 24 seats, the top row means that's the ending. How many seats in the entire section? Okay, so let's write out the equation because I don't want to have to go back page. And let's fill in, let's see what we have here. So we know we have A1. A1 is 8. We know we have AN, it's 24 because that's the last row. Okay, and we know the D is 2 because we're adding 2 every time. Those are the kind of things that I know. What am I missing in this equation though? I'm missing this N here. So can I find the N? I can. We learned an equation in the previous section that looked, like this. Okay, this is a common, most used one versus the other one. Okay, and so I can fill this all in and find the N, and then I can go find my sum. But I can't find my sum until I do that. All right, so AN is 24. A1, and then I've got N minus 1, and then D is 2. Okay, so I'm going to subtract 8. So this gives me 16, and minus 1, 2. Then I'm going to divide by 2. So that gives me 8 equals N minus 1, add 1. So N equals 9. So there was 9 rows in this section. So now I can go and find the sum. So I have 9 times A1, which is 8, plus 24, divided by 2. I'm going to do the math in the parentheses first. I'm going to add the top. I'm going to divide by 2. Actually, let me get my calculator out right now and not do this in my head. Multiply by 9, and I get 144. So there's 144 seats in this section. Okay, many times that you do this problem to find the sum, not every time. Sometimes they'll give you all the information, but a lot of times you have to go find something from this formula, whether it's D, or I guess it wouldn't be D because you don't use D, but whether it's AN or A1 or whatever N, a lot of times you have to use. So these are the 2 formulas that you need to write down. Okay? All right, let's go on to geometric. The sum of a geometric finite geometric sequence. So that means like the first 10, like there's a beginning and there's an ending. Okay? Now, the crazy thing here is notice we need the first term. You need the ratio. You need the number of terms that you're doing. There's the ratio. But you don't need the last term. So that's kind of a little bit of a difference between the last one we just did and this one. Okay? All right. So let's see if we can list. Here's a sequence. Let's see if we can list all the things we need up here. We need A1. That's 4. That's easy. There's A1 right here. Okay, we need the ratio. Remember how to find the ratio. It's the second term divided by the first term. So in this case, it's negative 4/3 divided by 4. So I'm going to go to my calculator. And I'm going to do negative divided by 4. Now I'm going to go ahead and turn this into a fraction because I don't want to round. Just FYI, I don't want to round any of this. And then it should tell you, how many terms. Okay, so we do need to know n, and you don't have to find this because you should be able to tell from this right here how many terms it is. So this would be if we want to relate it, okay, because anything to the 0 power is 1, so this would be 4. This would be, okay, and so this would be negative 4/3. So see how this is working? So how many terms are there in this sequence? Because they end it with this, and so you have to think about it a little bit. You do have to use your noggins. This is 4/9. So all these numbers tell you how many terms there are. They're not 10 terms. There are 11 terms because you start with 0, and so you'd count it as 1, 2, 3, 4, and get 11. So you do have to think about it a little bit here and use your knowledge. I'm going to erase some of this so I can use some space. Okay, so it did tell you how many terms. Now you could probably use this equation and figure out what the n is by using our logs or something like that. But okay, so we do have A1, we do have R, and we do have n. So I can use my formula. This is where it gets real tricky, you guys. You guys, some of you struggle hard about using the calculator. I sometimes don't why, but you got to get past doing your own thing and using the calculator in the right way. So be careful putting this into the calculator. You might want to practice using this one. Oh, I'm going to fill in the numbers real quick. So A1 is 4. 1 minus, this is going to be negative 1/3 to the 11th, all over 1 minus. Okay, and so the common mistake I see is that people, students, whoever, want to make this a plus and go ahead and decide that's what it is. Please don't do that. Remember PEMDAS, okay? Remember PEMDAS. Always remember PEMDAS. You learned it like in 7th grade probably with Dr. K or somewhere. But you learned PEMDAS a long time ago and you have to carry it with you forever. So do parentheses, okay, which we're going to do right here. But then we got to do exponents next. So do your exponents. Then you do your addition and your subtraction, okay? So be careful with the minus thing and the x. Just be careful, okay? So I'm going to go ahead and do this in my calculator real quick. Now remember, I'm going to use 1/3 because I don't want to round it at all. You might have to use, like I'm using my ANS button so I don't round. You guys got to get a little handy with your calculators and using the buttons. It just takes a little practice and a little work, just like everything, to figure out how to use your calculator. You've got to put anything in the denominator with parentheses around it. If you don't, you're not going to get it right every time. Every time. I feel like I've broken record on that. Okay? All right, so here's the answer I got. I got 3.00016,935. Okay, and it'll tell you how many decimals it wants you to put in there. I don't know. I mean, just follow the instructions. Okay, so I'm telling you, as you're going through this, you're going through this, let me see if I can get back, sorry. Going through this video with me, you need to stop and try to put this in your calculator and make sure that you can do that, okay? All right, let's move on. Okay, so the last thing we're going to talk about is infinite sums. And you may say to yourself, how can you possibly find a sum of an infinite number? Well, something will get closer and closer and closer to a number, like whether it's 0, whether it's a 1, and then to the point where it's out in an infinite world that decimal just doesn't make a difference. And so we actually do find the sum of a number. Okay, if you can find the sum, we say it converges. If you can't find the sum, well, that really makes sense, can't find sum, then you say it diverges. Okay, so they're going to ask you, does it converge or diverge? All right, so that's what it's talking about. All right, so I've got some examples here just to see what it looks like. So here's an example A, all right. Okay, so here's an example. And basically, as you know, as this keeps going out to infinity, you're going to get to the point where it's like, I mean, so many zeros and then a 1, and you're just adding the most minute number here. Okay, so that's why this will converge. Okay, and I'm going to tell you how to find the sum in the next screen. Okay, so and here's something else that I'm going to tell you in the next screen, but I'm going to go ahead and tell you. Here's how to know if you can find the sum of an infinite sequence or not. Okay, R, the absolute value of R has to be less than 1. All right, so it can be a negative number, but it has to be less than 1. So I would do R, so 0.01 divided by 0.1. That gives me R is 0.1. So that checks off. You can find the sum of this infinite series. Okay, so let's apply that knowledge. I was going to tell you the next slide, but this just makes it a lot easier. So R here is 20 divided by 10. Well, that's 2. That's not less than 1. So, sorry, this diverges. Okay. And what about this one? This is a tricky one. So negative 1 divided by 1. Now notice how this is written. By the way, notice how these are written. There's not commas. It's okay. It's still a sequence. It just tells you whether the number is positive or negative. And it's showing that it's a sum. So you would add all these numbers together. Okay, so these numbers oscillate, by the way, and they do not converge. So this would be negative 1, and that number, absolute value, is not less than 1. So this diverges. Okay, so this is a good indicator if something converges or diverges. All right, so now let's do one, and here's the formula to find the sum. Okay, it's a pretty basic formula. You get just the first term, and you got the ratio. Now remember this, you can only do this if this happens. All right, so I don't have it on here because I have all positive. It's just the ones I've found. No coincidence, but let's say you get negative 0.5. The absolute value of that is less than 1. So that does work. Okay, so make sure it's the absolute value. Okay, so let's check the first example I have here. So 1/2 divided by 1, 1/4 divided by 1/2. This is going to equal, my ratio is going to be 1/2. So if it's a infinite, which means it has no ending, they don't tell you find the sum of the first blah 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 terms, then it's called infinite. So you find the sum, you do A1, which is 1, over 1 minus 1/2. So the sum of this, I'm going to do it with my calculator real quick, is going to be 2. So this number will get closer and closer and closer to 2. Okay, because you did 1 plus, and then all these numbers are going to get closer and closer and closer to 2. Okay, and then at some point out here, it's going to be so minuscule. Is that a good word? Minuscule. So tiny that you're adding on that it doesn't even really make a difference out there in the infinite world. All right, so let's do B. Let's do 1 over 32, 1 over 64. Let me just see what that is really quick. I have no idea. Okay, so my ratio here is 2. So guess what? This I'm going to say, I'm going to converge. Remember, converge, and this is diverge. You can't find the sum of this one right here. Okay, no go. All right, so that's the last part of this, the infinite. Oh, just kidding. It's not the last part. I've got one more thing, the summation notation. I think most of you have seen this. I hope so, because it's probably on some of your standardized tests. But this is what summation notation looks like. It's a big Greek letter. Looks like an E. Okay, and this is where you start. And this is where you end. This is the number you end. And this is your formula that you follow. So for example, I'll show you real quick. I have 3K down here. So I'm going to start with K equals 1. So I'm going to start with, I'm going to put a little arrow because, well, it's probably not. Okay, so I'm going to do 3 times 1 plus 3, it's summation, so we're summing this up. 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. See, I'm stopping at 5 because 5 is where I'm stopping. And so I would go add up all of these numbers. I'm going to do that real quick. So I get 45. Now there is a summation button in your calculator, and I have to be really honest, I'm not exactly sure where it is. It's probably under math somewhere. You might, I'm not really sure. I haven't used it in forever because it's just as easy to type it out. So there is a summation button in your calculator. These are pretty easy. I hope the ones on your homework are pretty easy. So I'm going to start with 5, go to 8. So I do 5 squared plus 6 squared plus 7 squared plus 8 squared. So that would be 25 plus 36 plus 49 plus 64. So 25 plus 36 plus 49 plus 64 would be 174. Okay, so I did want you to see, I think that's it. Yep, that's it. I want you to see the summation notation. Again, there is a button on your calculator, and it will come to me. If you don't find it, let me know if you need it. Like, we did not need it here. So I cannot remember where it is. I'm looking on my calculator right now, and I just can't remember. So let me know if you need that and can't find it. You might be able to Google it. That's probably what I would do if I was coming back to you guys and letting you know. All right. Let me know if you have any issues on this homework. I think it's pretty short, maybe 10, 12 questions. And so get it all done.